This is questions 10 and 11 in exercise 16.1 in Project Maths 2. Question 10, we have 29 sine theta is equal to 21, where theta is between 0 degrees and 90 degrees. If the tan of theta is equal to 21 over k, we have to find the value of k, and we're told that k is an element of n. This last bit just means that k is going to be a positive whole number. That's all that means. So let's first of all take the information we have. Tan theta is equal to 21 over k, and we'll construct a right angle triangle with that information. So if theta is down here, the tan of any given angle is going, in the right angle triangle, is going to be the opposite over the adjacent. So if theta is here, the opposite's over here, which means this side is length 21, and this side is length k. Now we're going to use this other bit of information that we were given. We were told that 29 sine theta is equal to 21. Well, this bit on the left means 29 multiplied by the sine of theta. But we want sine theta on its own in order to get any kind of information out of this. So sine theta is equal to, and if we bring our multiply by 29 across the equals, just like we would in algebra, we get 21 over 29. And since we know that the sine of any given angle in a right angle triangle is the opposite side over the hypotenuse, our opposite side is 21, just like it is in our diagram already, and our hypotenuse is going to be 29. So we get to mark the hypotenuse in like this. And now what we have is a right angle triangle with one side missing. So what we can do is we can use Pythagoras Theorem to solve that out. So it's going to be 29 squared is equal to k squared plus 21 squared. And if we square them out, 29 squared is 841, k squared is k squared, and 21 squared is 441. That means that 841 minus 441 is equal to k squared. So k squared is equal to 400. So k is going to be equal to the square root of 400. So k is going to be equal to 20. So that's how we get the value for k in that question. Now we'll take a look at the next question down. Question 11. The diagram shows a triangle with lengths of sides 3, 4, and 5. We have to first verify that sine theta over cos theta is equal to tan theta, and then we have to evaluate the square root of sine theta tan theta all over cos theta. I'll do this one bit at a time, so we'll start with part 1. Although what we'll do before we do any of them is we'll actually write out what the sine, cos, and tan of theta is. Alright, sine in a right angle triangle is the length of the side that is opposite the angle over the length of the hypotenuse. So it's going to be 4/5. The cos of an angle is going to be the length of the side that is adjacent to the angle over the hypotenuse. So it's going to be 3/5. And the tan of the angle is the length of the side that is opposite the angle over the length of the side that is adjacent to it, and that's going to be 4/3. So we're going to sub all those values into this equation that we were given and see if it all works out. So sine theta over cos theta becomes 4/5 all over 3/5, and we've been told that that is equal to 4/3. Well, on the left, 4/5 over 3/5 is another way of writing 4/5 divided by 3/5. So we actually have 4 over 5 divided by 3 over 5. And that's equal to 4 over 3. And when we're dividing fractions, what we actually do is we invert the second fraction and we swap the division sign out for multiplication sign. So this bit on the left of the equals becomes 4 over 5 multiplied by 5 over 3, which we've been told is still equal to 4/3. If we actually multiply that out, we got top by top, bottom by bottom. 4 by 5 is 20. 5 by 3 is 15. But 20 over 15 can be simplified because both 20 and 15 can be divided by 5. And if we do that, we get 4/3, which is equal to 4/3. So we have verified that the sine of theta over the cos of theta is equal to the tan of theta. Now for part 2, we just got to sub in our values again into this. So 4/5 sine theta tan theta is sine theta multiplied by the tan of theta. So it's going to be 4/5 multiplied by 4/3. And that is all over the cos of theta, which is 3/5. And then that all goes under the square root sign. So on top of our fraction here, 4/5 multiplied by 4/3 is going to be 16 over 15. And on the bottom, our 3/5 doesn't change. But as we said with the previous one, when we were doing division like this, it's another way of, or doing a fraction like this, it's another way of writing division. So what we actually have is 16 over 15 divided by 3 over 5, all under our square root, which means we have 16 over 15 multiplied by 5 over 3, all under our square root. Now when we're doing that multiplication out, this 16 over 15 multiplied by 5 over 3. We can do a little bit of cancellation above and below the line. So this 5 and this 15 can both be divided by 5. If you divide 5 by 5, you get 1. And if you divide 15 by 5, you get 3. And now we can do our multiplication out with slightly simpler numbers. So we go 16 by 1, which is 16. You get 3 by 3, which is 9. And that is still under the square root. And now we just have to take the square root of both of those numbers. So the square root of 16 is 4. And the square root of 9 is 3. So in the very end, that is what we got for part 2. And that is that.